this is a system because there's more than one equation. And we're going to solve this system. Yesterday we just wrote down systems, now we're going to learn how to solve the systems. And to recognize lines in standard form. These are lines in standard form, and so that's what we need first of all to solve by elimination. We're going to learn 3 different ways to solve, and depending on the way the problems are set up, one way might be easier than the other way. So we're going to solve this system by elimination. What does eliminate mean? Get rid of one of the variables so that we can solve for the other variable. And so these are standard form, so you see that the x's are lined up and the y's are lined up and the whole number. So I'm going to draw a line across the bottom, and I am going to add x's to x's. There wasn't a 1 there. I put it there to remind me that x by itself means 1x. So it's 1x plus 5x. But what happens when I add this one and this one together? A positive 2 and a negative 2. Another word for that is say eliminate. This is eliminated, cancels out. And then I add up negative 19 plus 1, and I get negative 18. Can we solve that? Divide both sides by 6, and x equals negative 3. That wasn't good. But these are, if I group these would be 2 lines. And what I'm finding when I solve it is an intersection point. Is x by itself a point? When we have our solution over here, it's going to be an xy point. So what do I need to have? I have the x, so I also need to have the y. So we go back and pick one of our original equations, whichever equation appears to be the easiest original equation. And we write it down again, and in place of the x, we substitute. In place of the x, we put the negative 3 because x is equal to negative 3. We just figured that out right there. Can we solve this equation right here for y? To solve for y, we need to add 3 to both sides to cancel this out. And then we need to divide by negative 2 to cancel this out. And the negatives will cancel, and so that's going to be an 8. So this is going to be a negative 3, and this is going to be an 8. If I graphed those 2 lines, they would have an intersection point at negative 3, positive 8. That's what I found when I found a solution. I found the intersection point of those 2 lines. Now, this was very difficult at all because those had just the right numbers that would make them eliminate. Let's try another one. Okay, so You need to have your equations in standard form to start with, or at least the x's lined up and the y's lined up and the whole numbers lined up. And this would be 1x right there. I put my 1 in there so I don't forget that x itself is 1x. And I add up all the columns. What do I get when I add a 4 plus a 1? And what happens to these? They're going to cancel out. They're going to eliminate. These cancel out. And this would be equal to negative 10. That's negative 9. That's negative 10. Can you solve this? Divide both sides by 5. I'm not finished. The answer is going to be a solution point. A point has an x and y value. I've only found the x value. And so I don't really know. I didn't really need that 1 right there. I go back to whichever one of these equations is the easiest to work out. I picked this one because it doesn't have any coefficients on the x and the y. I just figured out that this x is equal to negative 2. So in place of the x, I put the negative 2 because I figured out right there that x was equal to negative 2. Solve it for y by canceling this out. Write your answer as a point. When you write your answer as a point, be sure that you put x and then y. You can find y from either one of these equations. Either one of these equations is going to give the same y because it's the same this is the intersection point for lines. Now, if I have a choice of solving with this equation or this equation, which one looks easier? I picked this one because it looked easier. If I had used that one, I would have gotten the exact same number. Just might have taken an extra step. So, to solve elimination, you need standard form, or you at least need the x's lined up and the y's lined up and the whole numbers lined up because we're going to add up the columns. And I need to add the x's to x's. So when I add this x and that x together, what's going to happen to my x's this time? These are going to cancel out this time. And negative 4 plus 2 and 8 plus 8, you add up the columns. And then you solve for y this time, because y was the variable that was left after I added up the columns. Now you go back to your original problem and pick whichever one that looks easiest. This one, they're about the same. See? Somebody said the bottom one looks easier because the 2 is a smaller number than the 4 maybe. Pick one of your 2 original equations, and in place of the y this time, because I solved for y, in place of the y, I'm going to put the 8. Was it a negative 8? Yes, I wrote down the negative 8. Okay. Then I have to solve for x. Good question. Why did I put that negative 8 in place of y? What does it say right here negative 8 is equal to? So where did I put it over here? In place of y this time, because of the way the number worked out, the x canceled and I solved for y. That's why this one is different than the previous one, because right here, what does it say? And so I put the negative 8 in place of the y. So this would be 2 times 8 is 16, and that would make it a negative 16. I am solving for x, so I need the x by itself. So I add 16 to both sides. I am solving for the x, so I need to cancel out the negative 3. And then I write my answer as the intersection point. That's unfortunate. I see people still copying this problem. To solve by elimination, we need standard. We need the we need. Once we have everything lined up, then we add x's to x's. What do I get when I add those together? They cancel out. And so then I add these two together. And what happens? They both cancel out. When they are canceling, negative 5 plus positive 5 makes a 0. This whole side zeroes out on this particular problem. And if I add that, I get negative 18. The x canceled out, the y canceled out, and over here I got a negative 18. Is it ever possible in this negative? It is not possible for 0 to equal negative 18. Now, remember that I told you that these represent lines and that I was finding an intersection. Why would I have difficulty with intersection points? And what do we call lines that do not intersect? These lines were parallel lines to begin with. Are they going to have an intersection point? No. So when the x's cancel out and the y's cancel out, and you get 0 equals something else that's not 0, that means they were parallel lines, so there is no intersection point. The answer is not possible. No solution. Okay. We have the x's lined up. And so what happens when we add these x's? Cancel out again. Okay, then we need to add the y's. What happens to the y's? But this time, what happens to the whole numbers? Is that possible? Can 0 equal 0? Yes. So what does it mean the answer is? Not just possible, the answer is all real numbers. Or sometimes you will see it written infinite solutions. Because what this means is I have a line, and the second line is sitting right on top of it. So how many intersection points would it have? Every single point on the line is an intersection point. And that's why all real numbers, every single number on the line is an answer. There's infinite intersection points. Now, it is helpful for some people to have a process. So here are the steps that I was using to solve by elimination.